Hello students, today we're going to talk about section 4.5, which is about proving lines parallel. This is basically all the types of proofs that we've done in the past, except one more step added on to the end. We've already learned the different ways that you can prove that lines are parallel, so here they are at the top. If alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, the lines are parallel. Corresponding angles congruent, the lines are parallel. And if consecutive interior angles are supplementary, then the lines are parallel. This one's not too common, but it may come up, so I would definitely be aware of it. However, the others are more common and they come up more, so these three are easier to kind of look out for. Okay, the process in a proof for proving that lines are parallel has three basic steps. So first you're going to prove that the triangles themselves are congruent. We should all be masters at this by now because we've been doing it for a long time. After that, then you're going to use CPCTC to prove that angles are congruent. Now, the angles that you're going to pick are going to depend on each diagram. So you might want to choose alternate interior angles. You might have to choose alternate exterior angles or corresponding. It depends on each diagram. But you're going to have to find out some angles that you want to be congruent and then say that they are by CPCTC. We might not be masters at that yet, but we soon will be. Last step, after you do CPCTC, use one of the four reasons listed above to then say if those angles are congruent, then the lines have to be parallel, and that's how you're going to stop your proof. Okay, I want to do a couple together and then give you some time to chime on your own. Proof number one, you're going to put your given information. Mark up your picture as best you can. These proofs, it's really important that you get a game plan going because you have to figure out which angles you need to list. Okay? C is the midpoint of AE, so that tells me AC and EC are congruent by definition of midpoint. We already know AB and DE are congruent, and we already know that these are right angles. So I'm just going to name them 1 and 2. Then I could say angle 1 is congruent to angle 2 because right angles are congruent. Okay, now we need to think of a way to prove the triangles are congruent. So first of all, I have a right triangle and two sides. One of them is the hypotenuse, the other one is the leg. So this is kind of like what we did the previous day in our last lesson. We learned about HL. Tells us that triangle ABC is congruent to, I need to make sure that I make the letters in order. So A, it's in between those two sides with the check mark, so that means it's going to match up with E. B is the other angle that's not the 90 degree, so that would match up with D, and then C is going to match up with C. Alright, so prove triangles congruent, check, we're done. Then we want to use CPCTC to prove that a certain set of angles are congruent. Alright, in this case I could say A is congruent to E. Well, if I want these lines to be parallel. So if A is congruent to E, would that work? Yeah, it would, because A and E are alternate interior. And if those alternate interior angles are congruent, then the lines have to be parallel, okay? So that's kind of like my game plan. I'm going to say A and E are congruent because CPCTC. That means if those are the same, the lines are parallel. The reason why the lines are parallel is because these are alternate interior angles, and if alternate interior angles are congruent, then the lines are parallel. Okay, not so bad. Is there another way that you could do this? Sure. Instead of using A and E, if I said that B and D were congruent, I would still have the same idea. So sometimes there's more than one choice. Let's try number 2. Again, I have a midpoint of AD, so AM and DM are congruent. And it's also a midpoint of BC, so BM and CM are congruent by definition of a midpoint. Got 2 sides so far. Well, anytime you've got 2 lines that cross to form a perfect X, we have vertical angles, so I'm going to name them 1 and 2. Vertical angles are congruent. And the reason why I'm doing this, remember, is because I first need to prove that the triangles are congruent. So now that I have that, I can see I have SAS. So triangle ABM, congruent to triangle A is going to match up with D, B is going to match up with C, and M will match up with M. And the shortcut, SAS. Alright, prove my triangles are congruent. Next step is to pick out a set of angles that will help me show lines are parallel. So I always recommend extend the line so you know which ones you're trying to show are parallel. And then pick a transversal. Maybe pick AD, or you could pick BC. It doesn't really matter. This one has 2 answers too. I'm just going to stick with AD. If I choose that transversal AD, which angles would have to be congruent? That would have to be angle A and angle D, because those are the alternate interior angles. Well, they are congruent, because corresponding parts of congruent triangles are congruent. If that happens, then the lines must be parallel, because they're alternate interior angles. So whenever you see this in the statement that's asking you to prove that lines are parallel, these should always be your last 3 steps. Prove that triangles are congruent, then CPCTC for some type of angles, it's going to depend, then the lines are parallel. Okay, let's give it a try on the back. Go ahead and flip to number 3. Alright, number 3 we have given information again. Give me 1 second, mark this up. So I marked up my picture just from the given. I see that we have ASA. But I'm going to stop for a second because if I look at this, it's a bit odd. NP is this line and VQ is this line here. How are these lines related to these triangles? Well, the only angles from the triangles that are kind of connected to those lines are these. I'm going to name them 1 and 2. So angles 1 and 2 are connected to the lines and they're part of the triangle, and they're on the outside of the parallel lines. So that means that they're alternate exterior. Is there a way that I can prove that those angles are congruent? Yes, there's 2 ways. So I'm going to do the first way first, how we said ASA. So these triangles, M and P, M matches up with R, N matches up with Q, and P matches up with V. Those triangles we said were congruent by ASA. Then I can say that angles 1 and 2 are congruent because they're corresponding parts of those congruent triangles. Alright, now these are alternate exterior angles, and they're congruent. So that means the lines are parallel. And you're all set. See if you can get example number 4. This one gives you parallel lines and a set of congruent angles. So when you know these lines are parallel, that will help you figure out some other information that will help you decide how to prove these lines are parallel. Okay? Jumping down to number 5. So XZ and VW are congruent. XW and YZ are congruent. And X is the midpoint of VY. So that means these have to be congruent. That's going to be my next step. Vx is congruent to Yx because definition of midpoint. Alright, this one's pretty easy to see, side, side, side. It tells me that these triangles are congruent. VXW and XYZ, SSS. Now, which sides am I trying to show are parallel? XZ and VW. There's only one line that really cuts through both and gives us information about both the triangles. That would be this one here. So notice these angles are formed by the parallel lines and that one transversal. It also has corresponding angles. So to make it easier, number them for yourself. 1 and 2 have got to be congruent because they're corresponding parts of two congruent triangles. That means these are corresponding angles in the parallel lines. So if corresponding angles are congruent, then lines are parallel. So XZ is parallel to VW. Done. If you need some more help with these, you can come see me after school to make an appointment, or you can look in your textbook. Remember, this was section 4.5. Okay? In general, you always want to follow this process. Prove triangles congruent. CPCTC for some type of angles. Depending on what type of angles you chose, then you can prove that the lines are parallel. Hopefully this helped you out. If not, please come see me. Thanks so much.